Hi, today is gonna be a repair video, and this is Antelope ultra-low jitter clock generator, and this device is used in studio or TV video broadcasting or whatsoever, where you need very low jitter clock generator to control or to give very precise clock for your devices. And this device doesn't turn on, and I suspect that the problem here is the power supply, which is probably a switching power supply. So let's put this on the bench and see what's inside of it. Yes, I was right. There is definitely a problem here. As you can see, there are blown resistor, and there is some damage here over this part, over this portion of the board. And I'm 100% sure that this MOSFET is short. So let's check with the multimeter what are all of the other damages. Here's the fuse. It's okay. There is a resistor next to the fuse, and it's open. Maybe let's measure its resistance. Yes, it's open. Next we have a bridge rectifier. And it seems to be okay. Yes, it's okay. Come on. Sorry. I can't measure this capacitor, but I'm going to remove the board later because I need to check this capacitor as well. Here is the MOSFET, and yes, it's completely short. So I need to change this resistor and this MOSFET for now, and these resistors here. This is the gate, so this is the gate resistor, and it's blown. Here is the snowball circuit, so let's see the components. This resistor seems to be okay, and the diode here is also okay. What we have more, here is the output diode. It's okay. Okay. Since there is just one diode, I suspect that the entire circuit works with a single DC voltage. Maybe it's 5 volt, or maybe not. Let's see the entire board here. Here we have a couple of transistors, maybe. Yes, there are some transistors. They are probably some portion of the power supply. I'm not sure. Here we have some other chips and a small board with a black box. Maybe it's a transformer, I'm not sure. And here is a big custom box or whatsoever. Antelope isochrome GMM Advanced Jitter Management Technology. And finally, here is a analog device. It's written ADV7301. I'm not sure what's that chip. Probably it's a microcontroller with some other features, but not quite sure. Here we have some transformers for isolating these two outputs, and another one here. Let's move to the power supply again. Here is the TL431 precision reference. It's a precision zener whatsoever, and the components across this, and this is the optocoupler. There should be a cutout under these two components for better galvanic isolation. Since this portion of the power supply is not working, I think to try to power the entire unit from here. And let's try to measure something. So here is the positive output, and I believe I can use this metal part here as a ground. So if I connect my test lead here, probably if I touch here, yes, there is a short, which indicates that the secondary coil of this transformer is okay also. So my idea is to use my power supply, WAP power supply, to power this thing, this unit, to see does it work. Here is my simple setup. These two wires go here, where is the positive output of the switching power supply, and the negative wire goes to the ground or to the chassis. So let's start with, okay, something like that. It's 200 microamps, and I'm going slowly to increase the voltage. Okay, I saw some activities here, which is great, but it's still at the constant current, so I'm going to increase the current as well, and I'm trying with 5 volts, let's say. Seems to be okay. Okay, now I have some activities here. I don't know what means that, but maybe I will turn on this and turn off actually and turn it on again. Okay, it looks much better now. Maybe there is an oven LED which blinks. Probably it takes some time to heat up the crystal oscillator. My idea is to connect my oscilloscope next to the outputs to see do I have the proper waveform taken out of the outputs. It's working pretty good. Let me show you. Here we have 48 kilohertz. Let's move to, what's that? 192, and here we have the same frequency. And I'm switching, reducing the frequency. Showing that the entire circuit of this unit works. And, well, I have to change these components. Okay guys, finally comes the moment of truth, and this is my auto transformer. It's there is a huge auto transformer here, and using this dial I can increase the voltage from 0 up to 260-70 volts, something like that. This unit has 2 knobs. This one enables a WAMP inside of the unit. There is a series WAMP, so here the WAMP is in series, and in this position is shunt. So usually when I turn or when I power up for the first time a new device or a repaired device, I use this WAMP in series, and here is the output to the device. So let's turn the unit, and here, as you can see, there is a power meter. This unit is on, so I'm going to slightly increase the voltage. As you can see here in this display, there is a 0 volt right now, and carefully watching, I'm watching the current, the power and the current as well. Usually the power is more important for me. So the power is is increasing. Okay, and the unit starts. The unit starts at 20 volts AC. I'm going to increase the voltage. $70. Let me show you the entire picture. 100 volt. It consumes about 7.5 watts for now. I'm still careful because it could blow, but maybe I think it's okay. Yes, 200 volts. And here we have 230 volts, which is the European voltage. And this unit consumes 7.2 watts. And as you can see, it works okay. Let's turn it off from here. And the idle power is 0.3 or 4 watts, which seems to be okay. I hope you enjoyed the repair of this Antelope clock generator. If so, please like, share and subscribe to my channel. Bye bye.